Hello my dear students, welcome to today's lesson. So I am going to discuss questions related to properties of matter. As you can remember, in the lesson, we started off by discussing what matter and energy are. So then we discussed what particulate nature or discontinuous nature of matter is with examples and activities. Thereafter, you were able to understand what solids, liquids and gases are, the three physical states of matter. Then, we saw how we can classify matter into pure substances and non-pure substances or mixtures. Pure substances can be further divided as elements and compounds. And as you know, elements have certain fixed physical properties. There are many physical properties like brittleness, ductility, malleability, thermal conductivity, electrical conductivity. But the density, melting point and boiling point are fixed values for pure substances. We did activities to understand these as well. And thereafter, you can remember we classified elements as metals and non-metals. Again based on their physical properties and many other properties. And finally, we discussed the day-to-day or daily uses of all these substances for us. So, I'm sure you all have a very good understanding of the lesson and you would have already answered the questions given in your textbook. If not, first answer the questions by yourself and then you can listen to my discussion. So, grade 8, unit 4, exercise. The first question. For the following questions, select the correct answer or the most suitable answer from the responses given. So, you all know why they say select the correct answer or the most suitable answer. For some questions, there is only one answer that's correct. So, that is the correct answer. For some questions, there can be more than one answers that are similar and correct. Out of that, you have to select the most suitable answer. So, those are the MCQ types questions, multiple choice questions. I am sure you are familiar with them. So, we'll start with the first question. Which of the following responses contains only matter? So, what is matter? Anything that has a mass and occupies space. So, that is matter. Under matter only, we have pure and non-pure substances or mixtures. Then there is the other one, that is energy. What is energy? Energy doesn't need to occupy space and also it does not have a mass. So, you know examples. Light energy, heat energy, sound energy, all those are different forms of energy. Whereas matter, air, water, then all the soil, solids, different types of solids, the metals, non-metals, everything come under matter. So, we'll look at the answers. First one, air, water and light. So, in this, air and water both are matter. Two different physical states, gaseous and liquid state, but both of them have a mass and both of them occupy space. But light is a form of energy. So, we need to have the answer that is only matter. So, this is not correct. Then the second one, water, yes, it is matter, but heat is not matter. It is a form of energy, heat energy or thermal energy that gives rise to temperature. You all are familiar with that. Then a brick, you all know what a brick is. Brick is used to construct walls and buildings. So, brick again has a mass and occupies space. So, both water and brick are matter, heat is energy. Then the third one, electricity. Electricity that is needed for the function of electrical equipment like light bulbs, radio, television, computers, all of those. But it is a form of energy, not matter. Then again brick, as I said, it's a solid matter. So, that is matter. Then ink. Ink, the ink we have in pens, printer inks, although it's in the liquid form, it does need space and it has a mass. So it is a liquid, that is a matter. So here again, brick and ink are matter, but electricity is form of energy. Then the fourth one, a brick, ink and air. Brick is a solid, ink is a liquid, air is in the form of a gas, and also they are all in the form of non-pure substances, but they are all matter. So the correct answer is a brick, ink and air. I am sure you all got it correctly. Then the second one, a property only common to solids and liquids. So how do we get the solids and liquids? You can remember that, students. Now in solids, we have the solid here. Then let's say this is the liquid and we have a gas. So what happens there? Solid, all the particles are very tightly packed. And there is very strong interaction between the particles. Because of that, they have a fixed volume, they have a fixed mass anyway, and also they have a fixed or definite shape. That is solids. The particles cannot move freely. Whereas if you take the liquids, there the liquids are slightly far apart. They can move randomly because the interaction between the particles is less compared to solids. So because of that, they have a definite volume. They take up the shape of the container that they occupy. Either the complete shape or the part of the container that is filled by the liquid. So that is liquids. Then if you take the gases, the particles are randomly arranged. There is very less interaction or no interaction between the particles of gases. They always involve in random free movement. Because of that, they do not have a definite shape. They take up the space, the complete space of the container they occupy. So that is gases. Then if you compare all these three, gases can be compressed easily. Why? Because there's lot of space between them, so you can compress them. What is compressibility? By applying a pressure, you can decrease the volume of gases. But that is not possible with solids and liquids. So you are familiar with all three states and their properties. So now let's look at the question. A property only common to solids and liquids. That's very important. Only common to solids and liquids. So not for gases. If we look at the answer, having a definite shape, that is only in solids. Both liquids and gases don't have definite shape. So that is not correct. Then having a definite volume. Yes, both solids and liquids have a definite volume. Both of them definite volume. Definite volume. That is correct. Then the ability to compress, third one. That is only seen in gases. Solids and liquids cannot be compressed easily. Then the free movement of particles. That is seen in what? Gases have very free movement, but liquids also has somewhat free movement. But solids cannot move freely. The particles of solids cannot move freely. So that is also not common to solids and liquids. So only property that is common to solids and liquids is that they have definite volume. So out of the four answers, having a definite volume. So I am sure, students, you got these two correctly. So with that, now I am going to move to the next slide. Question number 3. When a drop of ink is added to a vessel of water, the color of ink spreads throughout water. So you all know this observation. What do? We take a vessel containing water. Into that you put a drop of ink and water. and you see the color spreading. How is that possible? Now, water is made up of water particles. Ink is made up of ink particles. So, let's say here these are water particles. And if I use a different color, we'll say black color ink. So, ink, when you put the drop inside, the ink particles tend to move between the spaces of water particles. Why is that happening? Because both of them are discontinuous in nature. What is the meaning of discontinuous nature? The matter is made up of particles with spaces among them. So, because there are spaces between water and ink, the ink particles are able to move through the water particles. That is why the color spreads. So, this is an example of what? The discontinuous nature or particulate nature of matter. Or it is an evidence that shows that both ink and water are particulate in nature. I am sure you all can remember that activity. So then, when a drop of ink is added to a vessel of water, the color of ink spreads throughout water. That is that activity. Which of the following responses explains this observation best? So here, look at that statement. Which of the observation best? Responses explain this observation best. So that means there will be two or more answers that are somewhat correct. But out of those, you have to select the most suitable answer. So this is the question where you need to select most suitable answer. First one, water is discontinuous. That is correct. Water is discontinuous. That is correct. Ink is discontinuous. That is also correct. So both answers are correct. Now can you select one from these? No, because both are equally correct. So we have to look at all the answers. Water and ink are discontinuous. That is the most suitable answer. Why? That is why ink moves through water. So this is also correct. Then ink is discontinuous and water is continuous. That is of course incorrect. So this is incorrect. You won't get this as the answer because here it says water is continuous, which is not correct. But the first three answers are correct. You have to select the best answer that explains the observation. So that says water and ink are discontinuous. That is the most suitable answer. So that is what you need to select. Now when you all look at a question like this, students, don't just look at the first one. First one is correct and don't select it as the answer. Although that's correct, first three are correct. And out of those, the third one is the most suitable answer. So always when you answer questions like this, even though the first answer is correct, you have to read all four answers. That's very important. Then the fourth question. Which of the following is a pure substance? So, pure substances and non-pure substances or mixtures. What is the difference? Both are matter. In pure substances, all the particles that make up the substance are identical. Whereas in non-pure substances or mixtures, there are more than one component. Now, for example, if you take hydrogen gas, hydrogen gas is made up of only hydrogen particles. Nitrogen gas is made up of only nitrogen particles. Then water is made up of only water particles. But if you have nitrogen gas, hydrogen gas, water vapor, carbon dioxide gas and other gases together, then there are all the particles together. For example, air. Air has nitrogen, hydrogen, carbon dioxide, water vapor. So in that, there are more than one type of particles that make up air. So air is a non-pure substance, whereas nitrogen, hydrogen, all these gases are pure substances. So you know examples, you know the difference. So then, if we look at the answers, bottled water is what? There is water. In addition to that, what are there? There are minerals in it. Now, if it was pure water, it is tasteless, odorless, colorless. But the water, bottled water that you drink is consumable, drinking water, but it does have some minerals or salts dissolved in it. So, that is not pure water. So, it is not a pure substance. It is a mixture. So, it's not a pure substance. Then fizzy drinks. Now, from that name itself, you all know, as you open the bottle, you get the fizzing, the gas bubbles evolving. So, that means there is a gas dissolved in fizzy drinks. You all know the gas carbon dioxide. In addition to that, there can be different colors, flavors, you get a taste. So, there it is not a pure substance. It is a mixture, non-pure substance or a mixture. Then the third one, colorless toothpaste. Now, colorless toothpaste, it doesn't have a color. It can be transparent, but still there are many components in that. Why? It has to be a semi-solid substance. It should not get spoiled. It has to make your teeth clean. It has to make your teeth white. So, for all those, there are many different substances present together. There can be elements, there can be compounds all present together. So, that is a non-pure substance, a mixture. So, bottled water, fizzy drinks, colorless toothpaste, all those are non-pure substances. Fourth one, crystals of sodium hydroxide. Now, sodium hydroxide, from the name, you can remember, it is made up of sodium, oxygen and hydrogen. You all know the elements that make up sodium hydroxide. But once they combine and form the compound sodium hydroxide, only sodium hydroxide particles are there in crystals of sodium hydroxide. So, that is a pure compound. Crystals of sodium hydroxide is a pure compound. Then the fifth question, the property of crumbling upon the application of a small force is called what? You all know that. When you have your pencil, you sharpen your pencil, you have the nib of the pencil lead, but when it falls down, due to that force, the nib breaks. Even if you just press it hard with your hands, if you try to break it, you can break it easily. What is that nature? Brittleness. Glass, if you hammer a piece of glass, it breaks into pieces. That is again brittleness. So, you all know this property. The property of crumbling upon the application of a small force is called brittleness. We look at the answers. Hardness. What is hardness? You all know diamond is very hard. Why? It can withstand high pressure, it can withstand wear and tear. That is why we use diamonds to cut glass. It's a very strong substance. It's an element. It's a very strong substance. So, that is hardness. Then brittleness, like we said, crumbling upon application of a small force. Glass is brittle, graphite is brittle. So, that is brittleness. Then elasticity. What is elasticity? You all know rubber bands. You apply a force, you pull it, then it gets stretched. But when you release it, it goes back to its original shape and size. So, that is elasticity. Rubber band, elastic, all these are elastic in nature, elasticity. So, when you apply a force, their length or size, the shape changes. But when you release it, it comes back to its original shape and size. Even a spring that can be stretched and relaxed. That also has elasticity in nature. Then ductility. What is ductility? Metals are ductile. You can draw them into wires without being broken down. So that is why we have copper wires to conduct electricity. There is aluminium wires, cables, iron cables are there, steel cables are there. All that is possible because of ductility. But the answer to the question, the property of crumbling upon the application of a small force is called brittleness. That is brittleness. Is that clear, students? I am sure you all have understood it clearly. So with that, we'll move on to the next question. Question number 6. Given below are 3 ideas expressed by 3 students about the masses of equal volumes of water and kerosene. Now, what is the relationship between mass and volume? You can remember that. Mass and volume. It is density. When you say density, what is it? Mass of a unit volume of a particular substance. Solids have a density, liquids have a density, and also even gases have density because they do have a mass, but they take up the space. But usually gases are very light. That is why the gas balloons, hydrogen gas balloons and all go up. So you know that. So given below are 3 ideas expressed by 3 students about the masses of equal volume of water and kerosene. Now when you compare the density of water and kerosene, now can you remember that? Water, kerosene, which has a higher density. Now we did an activity where we measured the mass of equal volumes. You can remember, and some values are given to you, so you know you can compare and understand which has high density and which has low density. If you take water and kerosene into a bottle, into a container, you shake it well and you let it to stand. What will happen? They will separate out into layers and always kerosene will be on top. Why? Because kerosene is less denser than water, or the density of kerosene is less than that of water. Water has higher density than kerosene. So if you take equal volumes, mass of a unit volume of a substance is what we call as density. If the density of water is high, when you take equal volumes, the mass of water is also high. Mass of water is high compared to the mass of kerosene. Why? Because the density of water is high. If we look at the masses, you take equal volumes of water and kerosene, their masses are equal. No. Why? Because water is more denser, so mass of water will be higher than that of kerosene. So the first statement is wrong. Then the second one, mass of kerosene is less. That is correct. Why? Density of kerosene is less, so the mass of kerosene is less. That is correct. And mass of water is greater. That is also correct. This is what we have discussed here. Mass of water is correct. Greater. That is correct. So out of the 3 sentences or out of the 3 ideas, mass of kerosene is less and mass of water is greater. Those 2 ideas are correct. So the correct response of these is or are only A, no, only B, no, only C, that is also not correct, only B and C, that is correct. Both B and C are correct. Is that okay, student? I am sure you can relate this to density. So then, question number 7. Which of the following substance is an electrical conductor? You all know what electrical conductivity is. They can conduct electricity. You can remember we had a circuit. In between 2 ends, we had a space. Between that, we kept different materials and we observe whether the bulb lights or not. If the bulb lights, that means the electricity is conducted. You need to supply electricity using dry cells, you need to have a bulb, and you need to have conducting wires. So then you know what substances conduct electricity. Now if we look at the answers. Iron. Iron is a metal. Metals are good conductors of electricity. So this conducts electricity, or it is an electrical conductor. Wood. Wood doesn't conduct electricity. You all know that. That is why if someone gets electrocuted, you take a piece of wood and you have to break the contact. So when you do that, electricity is not conducted through wood. It does not conduct electricity. Then sand. Sand is also a substance that does not conduct electricity. That is why we have the earth wire. Earth has sand, and excess electricity or electric leakage is directed towards the earth. So earthing of current is possible because sand does not conduct electricity. Then wax, candle wax. Candle wax also does not conduct electricity. So usually the metals are good conductors of electricity. For example, copper, aluminium, iron, they are all very good conductors of electricity. In addition to that, non-metals are usually non-conductors of electricity. They don't conduct electricity except for graphite. Graphite, that is the pencil lead, is a very good conductor of electricity. So that is a non-metal that can conduct electricity. So remembering that also, you can identify the answers. Now iron is a metal. So wood, sand and wax, they are not metals. They are either other compounds or they can be mixtures. So they don't conduct electricity. Remember, usually metals are very good conductors of electricity. In addition to that, graphite, although it's a non-metal, it is a good conductor of electricity. So electrical conductors, it is ions. Is that clear, students? So then we look at the 8th question. What is the boiling point of pure water at standard atmospheric pressure? Now in this question, you have to look at many terms. Now you should know what boiling point is. What is boiling point? The temperature at which a liquid gets converted to the gaseous state. So water is converted to steam or water vapor. Steam is the gaseous state of water. So this happens at 100 degrees Celsius. You can remember that. So until all the water is converted to steam, the temperature does not change, but we will be providing heat. So that is the boiling point. It is a definite value for pure substances. So when you say pure water, boiling point of pure water is 100 degrees Celsius. So from that you can confirm that it is pure water. So what happens if there are other substances dissolved in it? Say, let's say seawater. Seawater will boil at a higher temperature than 100 degrees Celsius. So the boiling point of a pure substance will not be a definite value if there are other substances mixed with it. So with pure water, if salts dissolve in it or some other substance mixes with that, then it is not pure substance anymore. And then the boiling point will not be a fixed value. It can either increase or it can decrease depending on the substance that mixes with the pure substance. So you can remember that. Then, why do we say standard atmospheric pressure? That also you know. Now, when the height increases, now you go to the top of a mountain. There, due to the higher elevation, the atmospheric pressure is less. Then water will boil at a lower temperature than 100 degrees Celsius. So only at mean sea level, the standard atmospheric pressure, the boiling point of water is 100 degrees Celsius. If the pressure decreases, boiling point also will decrease. So you have to remember that. That is why always we have to say boiling a point of pure water, only water, pure water at standard atmospheric pressure. And you know the value, that is 100 degrees Celsius. If we look at the answers, 0 degrees Celsius, that is the melting point of pure ice at standard atmospheric pressure. So that is the melting point of ice. Then 30 degrees Celsius, it's a normal temperature. Usually even the room temperature, our atmospheric temperature can be 30. It can vary. So that is a normal temperature, but it is not the boiling point of water. Then we have 100 degrees Celsius, that is the boiling point of pure water at standard atmospheric pressure. And then between 30 degrees and 100 degrees Celsius, that is not possible. Boiling point takes a definite value for pure substances. This is a range of temperature. So that is not boiling point. So the answer is 100 degrees Celsius. So I am sure students, you all can understand that clearly. Is that okay? So then we'll move on to the next slide. Question number 9. What is the liquid metal that conducts electricity? So here, again you have to look at different terms. What is the liquid metal? What is the liquid metal that conducts electricity? So normally metals conduct electricity. So then you have to see what is the liquid metal. Now you know many metals: copper, iron, aluminium, lead, zinc. Then there is mercury. The first few metals I told you, copper, aluminium, zinc, iron, all those are solids. But mercury is a liquid, it is a metal, and it can conduct electricity. So in the answer, you have to check whether it is a liquid metal and whether it conducts electricity. So the answers: water. Water is not a metal, it's a compound. It's not even an element, it's a compound. Mercury, yes, it is a metal, it is a liquid, and it conducts electricity. So then the third answer is alcohol. Now you all know what alcohol is: ethyl alcohol. It is used in alcohol thermometers. It is a liquid, but it is not a metal. It is actually a compound. So from that itself, you can understand it is not the correct answer for this question. It is not a metal, but it is a liquid. Then there is the fourth one, wine spirit. Again, wine spirit, what we use in spirit lamps and all that, that is also a liquid, but again that is not a metal. It is a compound. So because of that, it does not become the answer. So all these, water, mercury, alcohol, wine spirit, all of them are liquids. Out of those, water, alcohol and wine spirit, they are all compounds. So they are not elements, they are not metals. So only metal is mercury, and mercury does conduct electricity. So that is how you select the answer. A liquid metal that conducts electricity is mercury. Then, question number 10. Some ideas expressed by students about the boiling point of a liquid are as follows. So you all know what a boiling point of a liquid is. Even in the previous slide, we discussed one question related to boiling point. So the temperature at which a liquid is converted to its gaseous state. If it is a pure substance, it is a fixed value. And always the boiling point of a liquid should be expressed at standard atmospheric pressure. You all know if the pressure changes, the boiling point will change. So always it has to be at standard atmospheric pressure, or at least we have to say what the pressure is. Then, if we look at the ideas, It is the temperature at which a change in state occurs. Is that correct? Yes. The liquid becomes a gas. So here the change in state, liquid becomes a gas. So this statement or this idea is correct. Then the second one. It is the temperature at which a solid turns into a liquid without changing temperature upon heating. That is wrong. Why? Because here the change is from solid to liquid. That is the melting point of a solid. So that is not correct related to boiling point. Then C. It is the temperature at which a liquid turns into a gas without changing temperature on heating. That is correct. That is the meaning of boiling point. So here it is the temperature at which a liquid turns into a gas without changing temperature on heating. So that statement or idea is also correct. So both these, it is a temperature at which a change in state occurs. That is correct. It is the temperature at which a liquid turns into a gas without changing temperature on heating. That is also correct. So the correct statements of the above are only A, no. Only B, no. Only C, that is also not correct. Only A and C, that is correct. Both ideas A and C are correct. I am sure students you have answered all these correct questions correctly up to now. So with that, I am going to move on to the next slide. Question number 11. That is the last MCQ in the first question. Which of the following is correct about the density of a metal? Again, you all know students what density is. Density is the mass of a unit volume of substance. And you all know density is a definite value or fixed value for a pure substance. So by looking at the density, you can confirm whether it's a pure substance or not. So then, if we look at the correct about density of metals and non-metals, can you remember? Usually, metals have high density, whereas non-metals usually have a low density. Comparatively, metals usually have a high density. It always takes a high value. You can't say always. There are metals that are lighter than water also. For example, if you put a piece of sodium into water, it will float. So that means sodium is a metal, but it has less density than water. But if you put a piece of iron into water, you know it will sink. So there you can't say always. It is usually. Mostly it takes a low value. That is also incorrect. Mostly it takes a high value. It takes a definite value. That is correct. Now since metals are pure substances, they will have a definite value for density. The third answer is correct. Densities of all the metals are equal. That is not. Like I told you all, sodium is less denser than water, whereas iron is more denser than water. So obviously their densities are different. So only correct statement or correct answer about density of metals is it takes a definite value. So here we are looking at density of metals. It takes a definite value. Why? Because metals are pure substances. It is a pure substance. So you all know melting point, boiling point and density have a fixed value for pure substances. Is that correct, student? So with that, we'll move on to the next question. This is the second question given in your textbook. Place the correct mark, right mark, if each of the following statements is correct and mark wrong if it is wrong. So you have to use the right or wrong symbol to mark it right or wrong. The first question. Air does not belong to the category of matter. Air does not belong. Now if you take air, you can remember we have done an activity. You take a balloon filled with air. Initially you weigh the balloon which is not inflated, which is not filled with air. You take the reading, it will have a mass. Then you inflate it with air. You blow the balloon, you tie it, and then again you weigh the mass of the balloon. Then you will see the mass would have increased. So from that, you can understand that air has a mass. So there are also students, when we just weigh the balloon, the mass of the balloon, you need to weigh the twine as well, because the thread or twine that you are using to tie the mouth of the balloon, or you can tie it with the balloon itself. So if you are using a twine, you have to measure the mass of the twine as well. So that you can make sure that air has a mass. You have done this type of activity in your previous grades as well. So you all know that air has a mass. So air does not belong to the category of matter is wrong, because it is a matter. Air is a gaseous state matter. So it does have a mass and it occupies space. Although it takes up the volume of the container, the full volume of the container, still it needs space. That is why it can be compressed. You can decrease the volume. That means it occupies space. So it is matter. So this statement is incorrect. This is incorrect. Then the second one. All matter has a particulate arrangement. That's correct. Matter has particulate arrangement or discontinuous nature. What is that? All matter, whether they are solids, liquids or gases, they are made up of particles and there is space between particles. So that is what we call as particulate arrangement. That statement is correct. All matter has particulate arrangement. Then the third one. Gas particles move freely. That is correct, no? When you take solids, liquids and gases, in solids the particles are tightly packed. So they can't move freely. In liquids there is little space between the particles, less interaction, attraction between particles. They can move around, but not as in gases. Gases, the particles move freely and randomly. That is why they don't have a definite shape. They don't have a definite volume. They occupy the full space of the container they are present in. So gas particles move freely. That is correct. Then the fourth one. Sun contains only energy. Now what is the sun? It is the natural energy source of the earth. It is a star. You get light energy, heat energy, those energy from the sun. But is it only energy? No. In the sun, there are so many gases. They are burning. There is combustion taking place. That is why there is very high temperature. From that, light energy and heat energy are being emitted. So we cannot say sun contains only energy. There is matter as well. There are changes taking place in the sun. So there is matter as well. So the fourth statement, sun contains only energy, is wrong. I'm sure you all can understand that. Although we get light energy, heat energy from the sun, there is matter as well. Then the fifth one. Solids, liquids and gases can be compressed easily. Is that correct? No. Why? Gases can be compressed easily. You can remember we did an activity. You take a syringe. There is air inside. You cover the open end of the syringe and you try to push the piston. Piston will move to a certain extent, but thereafter it will not move. So there you can compress it. By applying the force, you can decrease the volume of air. So air is gas. Gases can be compressed easily. But if you fill that syringe with water or any liquid and close the open end of the syringe and try to push the piston, is that possible? No. Why? Because liquids cannot be compressed. Same goes for solid. If you have a solid substance, if you have a piece of ice, by applying pressure, you can't reduce the volume of ice. You can break it. That's a different thing. But you cannot compress it. So solids and liquids cannot be compressed easily. Or they cannot be compressed. But gases can be compressed easily. So solids, liquids and gases can be compressed easily. That is not correct. It's wrong. Then the sixth one. A liquid has a fixed shape as well as a fixed volume. That is also wrong. Why? A liquid has a fixed volume. That's why we have a 1 liter bottle, 400 milliliter bottles. You have different volumes of drink bottle, water bottles. When you buy fizzy drinks, fruit juices, oil, they have different volumes. So, liquids have a fixed volume, that you know. But you take 1 liter of water into a beaker, it takes up the shape of the beaker, the space that it occupies. You pour it into a conical flask. Then the shape changes. So, it does not have a definite shape. So, that means a liquid has a fixed shape is wrong as well as a fixed volume. Fixed volume is correct. But the sentence is wrong because a liquid does not have a fixed shape. Then the seventh one. Copper is a brittle metal. That is also incorrect. Metals are not brittle. They are ductile, they are malleable. You all know what ductility is. It can be drawn into wires by applying a force. You have copper wires that conduct electricity. Then malleable. What is malleable? You can hammer them into sheets by applying a force without them breaking into pieces. So, they are ductile and malleable. That means they don't break into pieces when you apply a force. So, that means they are not brittle. If a substance has to be brittle, when you apply a force, it should be broken into tiny pieces. That does not happen with metals. And copper metal is not brittle. That is why we have copper sheets, we have copper wires. So, this statement is also wrong. Then, the eighth one. Sulfur is an electric conductor and a non-metal. Now, out of these, sulfur is a non-metal. That is correct. You have seen sulfur, a yellowish color solid substance. It is a non-metal. It's not a metal. It is a non-metal. That's correct. But it does not conduct electricity. The only non-metal that conducts electricity is graphite. Sulfur is a non-metal. It does not conduct electricity. I'm sure you can remember that. So, sulfur is an electric conductor and a non-metal. That is also wrong. Then the ninth one. Sonority is a property seen in most of the metals. That is what? Correct. What is sonority? You get a ringing sound when the metal is hammered onto an object, or if it is dropped on the floor, you get a ringing sound. That is what we say as sonority. So, the bells, handbells, electric bells, cymbals, all those musical instruments, you get the sound because of this sonority, sonorous nature. But there is an exception, you can remember. Lead is not sonorous. Lead is a metal, but it does not have sonority. So, that is why they have said sonority is a property seen in most of the metals. That is correct. All the other metals that we discussed, they show sonority. So that is correct. Sonority is a property seen in most of the metals. So then the last one, all metals have malleable and ductile properties. Now this is something you have to consider, students. Now normally what is malleability? That is the ability of metals to be hammered into sheets without breaking into pieces. Then ductile, they can be drawn into wires again by application of force and without breaking into pieces. Is this possible with all metals? Now you all know mercury. Now mercury is a liquid. Normally at room temperature it's a liquid. So you cannot make it into a sheet or you cannot draw it into wires. If it was a solid, yes, you can try. But as it is a liquid in the room temperature, it does not show malleability or ductility. So like that, there are some metals which are not always malleable and ductile at the same time. So because of that, all metals have malleable and ductile properties is not correct. Most of the metals, yes. You are familiar with copper sheets, iron, steel sheets. Then there are zinc plates and there are copper wires, aluminium foils. All those are there. But there are exceptions. So you can't say all metals have malleable and ductile properties. That's incorrect. So metals can have ductile and malleable properties but not always. So this statement is also incorrect. So you have to understand that, student. So we'll take a quick look at all the questions here. Air does not belong to the category of matter. That is wrong because air is matter, gaseous state of matter. Then all matter has a particulate arrangement. That is correct. All of them have either discontinuous nature or particulate nature. Same thing, two different terms. Then gas particles move freely. That is also correct. Gas particles do not have interaction between them or attraction between them. They always involve in free random movement. Then sun contains only energy. That is wrong because sun does contain matter as well. Then solids, liquids and gases can be compressed easily. That is also wrong. Why? Only gases can be compressed easily, but solids and liquids cannot be compressed easily. Then the sixth one, a liquid has a fixed shape as well as a fixed volume. That is also wrong. Why? Because liquids have a fixed volume, but they take up the shape of the container they occupy. They don't have a fixed shape. Then copper is a brittle metal. That is also wrong. Copper is a metal, but it is not brittle. Sulfur is an electric conductor and a non-metal. That is wrong. Why? Sulfur is a non-metal, but it is not an electrical conductor. Then sonority is a property seen in most of the metals. That is correct. Why? You know lead does not have sonorous sound. It doesn't show or give out sonorous sound. So most metals. Again, you can think of mercury. Mercury is also liquid metal. So there you don't hear the sound. So sonority is seen in most of the metals. That's correct. Same goes for all metals have malleable and ductile properties. That is wrong because all the metals don't have malleable and ductile properties. Most of them, yes. So that is what you need to remember. Although we classify metals and non-metals based on their properties, it doesn't have to be always. There are exceptions. Now, even for example, graphite is a non-metal, but it conducts electricity well. So, like that, there are exceptions. So, that is something you all have to remember, students. So, with that, I have completed this chapter where I have discussed all the exercises given in your textbook, and in the next chapter, I will discuss some extra questions with you all.